Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to go over an example problem, a problem in which you have to use conversion factors to find your answer. So let's go over this example. Let's go over this problem here. So in this problem you have a solution that's used to chlorinate a home swimming pool, and this solution contains 7.5% chlorine by mass. So what that means is that if you have, remember that a percent can be used as a conversion factor. Anytime you see a percent in a problem, you should be thinking, oh, conversion factor. Well, how can it be used as a conversion factor? Well, remember that a percent means out of 100. So 7.5% means 7.5 out of 100. Well, 100 of what? Well, whatever unit you want to use, but here we're talking about mass. So it's got to be a mass unit. So it's percent by mass. So it could be 7.5 grams per 100 grams. So in that case, it would be 7.5 grams of chlorine for every 100 grams of the swimming pool water, right? Or it could be kilograms, right? So it could be 7.5 kilograms of chlorine per 100 kilograms of pool water. So it depends on what unit you want to use or what unit that's convenient for the conversion. Okay, so we got 7.5% chlorine by mass in the swimming pool, and an ideal chlorine level for the pool. Oh, I'm sorry, I didn't mean water in the pool, I meant for the solution. So sorry, I misspoke. So it's 7.5% chlorine by mass in the chlorinated solution that's used to chlorinate the pool, not in the pool itself. So then you're told that an ideal chlorine level for the pool is 1 part per million. So 1 ppm. And so that can also be used as a conversion factor. So you have to know what 1 part per million means. That means that out of a million, 1 part is going to be chlorine, right? So it's like a percentage, but instead of per 100, it's per million. So if I have 1 part per million, that means 1 out of 1 million. So, and then again, that part can be whatever unit you want. So, for example, if I have 1 million grams of pool water, one of those grams, one would be chlorine. So I have 1 gram of chlorine for every 100 grams of the pool water. Or it could be liters, right? 1 liter of of uh, of the chlorine for every 1 million liters of the pool water. So it just depends on what unit is convenient to use. Okay, so with that information, we're asked what volume of chlorine solution, how much chlorine solution in liters would be required to produce a chlorine level in the swimming pool of 1 part per million if the swimming pool has a volume of 18,000 gallons. Okay, so there's a lot of information. They give us the density of the swimming pool water is 1.00 grams per milliliter, and density of chlorine solution, the density of chlorine solution is 1.10 grams per milliliter. Okay, so we got all this information, and they want us to find out how many liters of this solution, this 7.5% chlorine solution, do I need to put into the pool, this 18,000 gallons of swimming pool water, in order to get a level of 1 part per million, to get that ideal chlorine level. Okay, so first thing you want to do is pull out the information. So we already mentioned 7.5%. So 7.5%, we're going to change that into an equality. That means that out of 100, let's say, grams, of the solution, 7.5 grams of it, and here, let me specify this a little bit more. So grams of chlorine solution, then 7.5 grams of that is actual chlorine. Or, yeah, chlorine, I guess. Or you could have Cl minus. I think it's in the Cl minus. It doesn't matter. I'll just put it in Cl2. It doesn't matter, Cl2. So here's the equality that we can use as a conversion factor to help us get to our answer. So this is really important. So 100 grams of the chlorine solution equals 7.5 grams of chlorine. It's in grams because we're told it's by mass. Okay, and we have 1 part per million. So that means that for in the swimming pool, this is what we want. So for 1 million or 10 to the 6, right, parts, and in this case we can use liters, milliliters. What do I want to use? I'm going to use, let's see, I'm going to use grams. So out of 1 million grams of pool water, then 1 gram is going to be chlorine. So 1 gram of chlorine. So that's what parts per million would mean. So I have 1 gram of chlorine for every 1 million grams of pool water. Okay, so we have our conversion factors, and so we need to figure out where we're going to start and where we're going to end. So that's the second step. So first step, pull out your conversion factors that you are likely to use during the process of converting. And then the second thing is you need to figure out where to begin, where to end. So we want to end, right? We want to end what? The question. So find the question. The beginning of the question is the end of your problem. So what volume of the chlorine solution? So we want to get to where? Liters of the chlorine solution. Well, where are we going to start with? Well, the only thing we have left is 18,000 gallons of water in the swimming pool. So this is not related to anything, so it's not part of a conversion factor. So this is what we're going to begin with. We need to begin with 18,000 gallons of pool water, and then we're going to convert that to liters of the chlorine solution that I need to put into the pool in order to get a chlorine level of 1 million or 1 part per million. So we're going to start with 18,000 gallons of water in the pool. Okay, so we start by writing our conversion. So we're going to start with 18,000. So we're going to put 18,000 gallons H2O in the pool. So we need to get to liters of the solution. So we're started with the volume of the water in the pool. And so if we could get, let me start over. So this is a volume unit, and we're given percent here, and that's percent by mass. So we would need to get to a mass unit in order to use this. So let's go ahead and convert the gallons of water to mass of water. So we have gallons. We need to convert gallons to something. We have milliliters, right? We could use density to convert um, to mass, right? So here we have the density of the swimming pool water, right? So it's grams per milliliter. If I could convert gallons to milliliters, then I could use the density to convert to grams. So I can first convert this to liters, right? There's different ways of converting. You could use other conversion factors. I'm going to use liters. So let's the relationship between gallons and liters. 1 gallon is 3.7854. So 1 gallon of the water is equal to 3. What was it? 3.7854. 7854.1, and that's liters. Liters of water. So gallons of water cancel out. Now I have liters. Now I can convert this to milliliters, because I know 1 milliliter is equal to 1/1000th of a liter, or 10 to the negative 3 liters. Or you could use 1 liter is equal to 1,000 milliliters. Doesn't matter, they're both the same. So I'm going to put on the bottom liters. So I'm going to put down 10 to the negative 3 liters. That's 1/1000th of a liter is equal to 1 milliliter. Again, you could put 1 liter on the bottom and 1,000 milliliters on top. That's fine too. And so then this is liters of water, milliliters of water. So then liters of water cancel out. Now I have milliliters of water. Now I can use the density of water in the pool to convert to grams. So I'm told that it's 1.00 grams per milliliter. So I'm going to put milliliters on the bottom. So 1 milliliter is on the bottom. 1 milliliter of H2O. And on the top, it's going to be 1.00 grams of H2O. So milliliters cancels out. Now I have grams. So now I have mass. So now that I have mass, I can now convert the grams of water to the grams of chlorine that I want in the pool. So this is the level that we want. I want for every 1 million grams of pool water, I want to have 1 gram of chlorine. So I'm going to use this to convert from grams of pool water to grams of chlorine in the pool water that I want. So now we're going to convert. This is the same as 10 to the power of 6. So I'm going to put that on the bottom. So I have grams of pool water on top. So I need grams of pool water on the bottom here. So that's going to be 10 to the power of 6 grams of water. And then on top, I'm going to have 1 gram of chlorine. So 1 gram of Cl2 on top. So grams of the water cancel out. Now I have grams of chlorine in the pool water. Okay. So now I need to get to grams in the pool water to the amount of grams I need in my solution, right? So all of the grams of the chlorine that end up in the pool is going to come from my chlorine solution. So now I need to convert grams of chlorine to liters of the chlorine solution. So now I need to get back to volume, but this time it's going to be the volume of the chlorine solution, and I have given me the density of the chlorine solution, which is 1.10 grams per milliliter. So now I can use this as a conversion factor to convert from grams of chlorine to milliliters of chlorine solution. So now I can add another conversion factor. I'll continue on the bottom here. I'll continue over here. So I'm going to now multiply by the conversion factor of this. So since I have grams of chlorine on the top, I want grams of chlorine on the bottom. So 1.10 is on the bottom. 1.10 grams of chlorine on the bottom and 1 milliliter on top. So 1 milliliter of the chlorine solution. So now the grams of chlorine cancel out. Now I have milliliters of chlorine solution on top. Now I can convert that to liters of chlorine solution using the same conversion factor here. 1 milliliter of the water is equal to 1/1000th liters of water. So it's the same thing here. So since I have milliliters on the top here, I'm going to put 1 milliliter of the chlorine solution on the bottom, and I'm going to put 10 to the negative 3 liters of chlorine solution on top. So milliliters of the chlorine solution cancel out. Now I have liters of the chlorine solution. That is what I'm being asked for. They're asking me for liters of the chlorine solution that I need to put into 18,000 gallons of water in the pool in order to get a level of chlorine of 1 ppm, 1 part per million. So now I got everything set up. This is my conversions. So all I need now to do is multiply by everything on the top, divide by everything on the bottom, and I get my answer. And when I do that, I get 0.83 liters. So 0.83 liters of the chlorine solution. And also I want to point out the sig figs. So when you're trying to figure out sig figs, because I multiplied and divided, the rule is that the number of significant figures in your answer should equal the least number of sig figs in the measurements you use to multiply and divide. So here I have 18,000. So that has 2 sig figs. This has what, like 6? This has 6 sig figs. This is exact, so you can ignore it. This is 3 sig figs. This is exact, so you can ignore that. This has 3 sig figs, and this is exact, so you can ignore it. So the least number of sig figs is 2 from here. So I have 2 sig figs in my answer. And that, ladies and gentlemen, is how you solve this problem and how you use conversion factors like percentage and parts per million and density to help you convert from one thing to the other. I hope you enjoyed this video. If this was helpful and you enjoyed the video, then please, by all means, like the video, share the video, hit that like button over there. Also, make sure you subscribe to my channel, hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me. And I forgot one thing. If you have any questions or problems that you need help with, put it down below. Let me know, and I would love to do that problem for you. If you have a topic you want me to cover, put that down below, and I will make a video covering that topic if I haven't already done so. Thank you very much, and have a great day.